My project is about the energy of light. I was testing how different light bulbs could test the how different light bulbs could simulate the sun and see how far I could put away a solar panel and it still power the solar panel. And I tested two different types of light bulbs. I tested incandescent light bulbs and LED light bulbs. In my I found out that the LED light bulbs made less than the incandescent light bulbs, and this is an incandescent light bulb in here. And here's my graph explaining it. And that's the inches of light that it still powered the solar panel. And I did the project by having a ruler right here and then moving it slowly away and seeing how far it could go. And one thing I noticed is that when I turned this on, if I started off right here, it doesn't work. And then if I move it here and slowly push it back, then it can make it there. And the incandescent light bulb was able to do it farther because the incandescent light bulb generates more heat than the LEDs. And yeah, in conclusion, the incandescent light bulb could do it 5 times longer to power solar panel for 5 times more distance than the LED.
My project title is called Can Different Colored Lights Affect Pangra? So I'm Ruthie Carlson, and basically what I did was I grew 3 bean seeds, green bean seeds, and I put 2 in each pot, and I grew them in different colored light. One in red light, one in blue light, and then one in like a special daylight light bulb made specifically for planting plants. And so on after like 10 days or so of them not doing anything and they just looked the same, I decided to start a light and dark cycle. So basically turning off the lights for 7 to 8 hours every night so that they could get dark too. And I did that on day 11. And after 5 days of doing that, then 2 of the plants sprouted, the red light plant and this daylight plant. So the red light plants in the end did the best, and it was the so what I thought it would be, I thought it would be at the end the red light plant would be the tallest and healthiest, and I thought the blue light plant would be the shortest, and then I thought the daylight plant would also be really healthy, and I thought it would be like the thickest and stuff. But in my conclusion, I found that the red light plant was actually the tallest and the healthiest, and the blue light plant was the shortest. And then the reason my conclusion or my hypothesis was only somewhat correct because the daylight plant was not at all what I expected it to be. It was actually the shortest, and it was like really unhealthy. But it hasn't changed since the day we planted it very much. So yeah. Oh, and if I were to do this project again, I would probably change like instead of so I grew it with a daylight bulb, a light bulb, especially for daylight, for plants. And I might if I ever did this again, I would probably just grow it in this like sunlight because that has more like nutrients and it's better for it.
My name is Owen Mares. My question for my experiment is about if adding too much Mentos to cola, will the explosion always be more? First, I took needle and thread and made 3 strings, one with 1 Mento, one with 7 Mentos, and one with 14 Mentos. After that, I took 1 bottle of Mentos out, 1 bottle of cola outside, and the 1 string of Mentos outside, and then took the cap off the cola and put the 1 Mentos string in. After that, after the reaction was done, I put the cap on the bottle, moved it to the side, and repeated the process for the 7 and 14 Mentos. Once I was done, I brought them inside and weighed them. Overall, the 1 Mentos barely reacted, whereas the 7 and 14 Mentos were a little past were both past halfway empty. Um, in the end, my hypothesis that the more Mentos you add, the explosion was correct. Um, though 14 Mentos, though I doubled the amount of Mentos from 7 Mentos to 14 Mentos, the amount left in the bottle was not doubled. It was less.
Hi, my name is Harper Wadding. I'm in 5th grade, and my science fair topic is ice race. But my scientific question is, what liquid melts ice fastest? I really wanted to do this question because I like having cold drinks, and a lot of the times my ice melts before I can finish it, so I don't. It's not very cold. Um, my materials were 6 clear cups, a camera, lemon juice, Gatorade, milk, 6 ice cubes, tap water, Coke, and grape juice. I wanted to do lemon juice and Coke because they are both highly acidic. And I wanted to do Gatorade and grape because they're really close with sugar and acidity. Um, and water and milk because they are both pretty much alkaline. And my hypothesis was that the Coke and lemon juice would melt fastest because they're both more acidic than the other ones. Um, for my procedure, I did 1 and 1/4 or a fourth of a cup for all the liquids. I measured them, and I drew a black line for a tally mark, and I did another tally mark in intervals of 15, and the biggest tally mark length was 11, and it took two hours and 45 minutes. Um, the first that melted was tap water, which surprised me and proved that one of my hypothesis ideas was wrong. Its pH is a 7.2. It is considered alkaline, and it melted in about an hour and 15 minutes. The second one that melted was Coke. It has a pH of 2.4, and it is considered acidic, and it melted around 1 hour and 30 minutes. The third one that melted was lemon juice. With a pH of 2, it's considered acidic, and it melted around 2 hours and 15 minutes. That also shows that my hypothesis was incorrect for the lemon juice, but my Coke one was correct. The fourth place one that melted fourth was Gatorade. It has a pH of 2.9, and it is considered acidic. It melted around 2 hours and 30 minutes. In fifth place, there was a tie between grape juice and milk. Grape juice has a pH scale of 2.8, and milk a 6.8, and they are both considered acidic. They melted around 2 hours and 45 minutes. In the beginning, you can't really see any difference because it just started, but Coke, I noticed that Coke started to bubble a lot when I put in the ice. And at the 1 hour and 15-minute mark, water had melted and Coke had almost melted, but there was a tiny bit of ice left. And some fun facts about the project were that tap water, 7.5 pH, is lower on the pH scale than spring or bottled water with a 6.5, and spring and bottled water would be considered acidic because anything above 7.0 is alkaline, and anything below that is acidic. Another one is grape juice with a pH of 2.8 and Gatorade 2.9 are almost the exact same pH ranking, even though they melted different times. Thank you for watching my science fair project.
Hello, my name is Tyler McBain, and my science fair project was how long does a battery last in a flashlight? I tested 3 brands of batteries, Energizer, Delco, and Duracell. My statement of purpose was that my family was always wondering how long a battery lasted in a flashlight. And now after that I did this experiment, I'm going to share my results with them so they never have to wonder how long a battery lasts in a flashlight. My hypothesis was that Duracell batteries will have more battery life than Energizer, and Energizer batteries will have more battery life than Delco batteries. My research was that Duracell batteries last for about 10 hours, Energizer batteries last for about 9 hours, and Delco batteries last for about 8 hours. My materials were 3 flashlights of the same power, 1 Delco battery, one Energizer battery, and 1 Duracell battery. My procedure was to take a flashlight, put batteries in the flashlight, get a timer, or start recording on a phone, and start the timer recording when I turn the flashlight on. And then I leave the flashlight on until the battery dies, and then I would collect the results. My results were Energizer was in first place, lasting 144 hours, 12 minutes. Delco was in second place, lasting 96 hours, 31 minutes. And Duracell was in last place, lasting 94 hours, 15 minutes. My conclusion was that the Duracell price is higher, so I thought it should be the longest lasting battery. However, when I did my experiment, Duracell did not last the longest, Energizer did, by 49.95 hours. Therefore, Energizer is the best to buy out of these 3. And if I were to do the experiment again, I would change the power of a flashlight to see if I get different results and see if another battery lasts longer than a different battery.
Hi, my name is Harrison Feedy. I'm in 6th grade, and my question is, how does a windmill's blade design affect its speed? The reason I wanted to do this was because I was curious if the windmills that were used in like Iowa and Kansas were using like the best and most efficient blade designs. Some research I found was that in 700 AD, windmills were first invented and used. That the wind spins the blades in a circular rotation, which spins the axle, which generates electricity. Some materials I found, the materials I got were multiple connects, parts, rods, and connectors, 2 serial cardboard boxes, 1 fan, scissors, ruler, anemometer, and drafting triangles. The process I did was I created the Connects windmill, and then I cut out the different blades and measured them. I used the drafting triangle. I attached the blades to the windmill, and then I used the drafting triangles to line up their angles. I set up the fan 5 feet away. I turned the fan on, took its wind speed with the anemometer, and then I calculated its RPMs, and I did each blade and different angles, calculated their RPMs 3 different times to get an average. My hypothesis was that a blade at a 8 by 1.5 inch at a 45-degree angle will go the fastest. And in my results, it shows that my hypothesis was incorrect because actually the 6 by 2 at a 30-degree angle went the fastest by a lot. If I were to do this again, I would probably have the fan at different lengths and at different speeds.